Hello, and welcome to this short lesson on trigonometric identities and functions. Today I'll introduce three new trigonometric identities and how they relate to one another. We will then use these identities to simplify expressions, prove identities, and solve equations. Okay, so to start, what main trigonometric identities do you already know? Yep. Alright, perfect. So, we've got sine theta, we have cos theta, and we have tan theta. And we know tan theta is equal to sine theta divided by cos theta. Yeah. Okay. Do you know an equation we can use to relate sine theta to cosine theta? Okay, say I say sine squared theta and cosine squared theta. Brilliant, yeah. So, sine squared theta add cosine squared theta is equal to 1. Perfect. So that is actually everything we need to know to be able to move on to these new identities. Okay, so I'll just introduce them now. The first one I'm going to introduce is going to be secant theta. And that is going to be equal to 1 divided by cosine theta. The second will be cosecant. I might be pronouncing that wrong. Cosecant theta, which is equal to 1 divided by sine theta. And then finally, cotangent. And as you may have been able to guess, that's equal to 1 divided by tan theta. These names are quite long, and typically in mathematics you will just shorten them and write sec for 1 divided by cosine theta, cosec theta for 1 divided by sine theta, and then just cot for 1 divided by tan theta. Brilliant. So those are the new identities, but similarly to sine squared theta add cosine squared theta equals 1, we want a way to relate the identities together. Are you able to see a way we can manipulate this equation? I'll draw a line in red quickly. Can you see a way we can manipulate this equation to be able to have either sec, cot, and cosec in one equation? Yeah, perfect. So that's completely the way we do it. So if I just scroll upwards slightly, if we divide that equation by sine squared theta, as you said, we get sine squared theta add cosine squared theta. Let me just write the divides in. And then equal to 1 divided by sine squared theta. So let me just say that. So it's sine squared theta divided by sine squared theta, so that's 1. Add cosine squared theta divided by sine squared theta. If we look back, cot is 1 over tan theta, which is also equal to cosine theta divided by sine theta. So if you flip the tan upside down, that's what you would get. And so if we then square that, we'd get cosine squared theta divided by sine squared theta. So we have 1 add cot squared theta, which is equal to, and 1 divided by sine squared theta, and we said that is equal to cosec. So there's one equation linking all of them, or linking two of them together. And then, do you see another way we can get sec? Brilliant, yeah. So divide by cosine, and so we would then get, if I scroll down even more actually, right, if we divide by cosine, we'd get sine squared theta, divide by cosine squared theta, add cosine squared theta, divided by cosine squared theta, equals 1 divided by cosine squared theta, right? And we know sine squared theta divided by cosine squared theta, as we just discussed, is actually just tan squared theta. Add cosine squared theta divided by cosine squared theta, that's 1. And then equals to 1 divided by cosine squared theta. If I scroll upwards, we can see 1 divided by cosine squared, 1 divided by cos theta is sec, so 1 divided by cosine squared theta is sec squared. Okay, so with these two equations and the identities, that's actually everything we need to be able to simplify complex equations, prove identities, and solve very complex expressions and simplify them quite nicely. So let's start with proving identity. It's quite a difficult one, but we'll go through it together. And just to note, proving identity means changing the thing on the left to equal the thing on the right, basically. Okay, so we'll go through a few together, and then you can go and try it individually, alright? So, the question is cosec to the 4 theta minus cot to the 4 theta, and we've got to prove that's equal to 1 add cosine squared theta all divided by 1 minus cosine squared theta. Right. So, do you have any idea how we can start this? If not, it's completely fine. It's quite a difficult one, so... Okay, no worries. Let's change this. Let's not think about this for the moment on the left-hand side, and let's think about if I had x squared minus 9. How might we factorize that? Yeah, brilliant. So you do x add 3, and then x minus 3. So the difference of two squares, yeah? Well, that's exactly right, and we actually just want to do that for the cosec and the cot. So, if I rub that out quickly. So, like you said, we'll have the cosec squared theta, and we've got one of them added to cot squared theta, and then the other one minus, so yeah, cosec squared theta minus cot squared theta. Right, that's what we have at the moment, but if we remember, just above we have, if I underline this in red again, we have 1 add cot squared theta equals cosec squared theta, which means that cosec squared theta minus cot squared theta is equal to 1. And that's perfect, because it means we can actually change this equation, change this whole bracket to be a 1. So, if we now move on, we'll then have, just on the left hand side, we'll only have this bracket. So just cosec squared theta add cos squared theta. Yeah? Do you have any questions so far? You're alright? Yeah? Alright. If we're not sure about this difference of two squares, we can always just multiply it back out. So if we just do that now, so we've got cosec to the cosec, we've got cosec to the 4 theta, we have cot squared theta times cosec squared theta, so we've got add cot squared theta times by cosec squared theta. Then we have a minus, so that's that one. We have a minus cot squared theta times by cosec squared theta. And then we have the two cots times together, and that's minus cot to the 4 theta. Right? And if you see, these two cancel out, and we're left with what we thought we had. Okay, so that's perfect. We've done it right. Okay, so from here, what can we do? Right, well, why don't we write it out like we would normally? So we know cosec, we introduced it a few minutes ago, and we know that's third letter is an S, so 1 over sine squared theta, and then add cot, third letter is a T, so 1 over tan squared theta, but remember, 1 over tan is actually cosine over sine, so why don't we write that? So we've got, and it's all squared, so it's cosine squared theta all divided by sine squared theta. Okay, so that's what we've got at the moment, but because we have the same denominator, we can actually just add them together, right? So if we add those, we've got 1 add cosine squared theta, all divided by sine squared theta. Do just say if you have any questions, because obviously we just need to stay on track. So we're really almost there now. If I just rewrite the identity in blue, so this is what we want to prove it equals, and we're really, really close. Right? Perfect. So we have the top, let's give that a tick. Now we just need to change the bottom from sine squared theta somehow to 1 minus cosine squared theta. Do you have any ideas? At the start of the lesson, you did actually say how to do it. So you remember you said sine squared theta add, yeah, that's right, perfect. So is equal to 1. So if we move the cosine over, we've then got sine squared theta equals 1 minus cosine squared theta. If we put that into the new bottom, into the denominator, we then get 1 add cosine squared theta, all divided by 1 minus cosine squared theta. And that's exactly what we wanted, so we've proven it. Woohoo! Brilliant. So, if we had time, I would go through another example, or maybe two, and then give a few questions and just set a few questions and help them along the way to make sure they're going on track. And then I'd give some learning objectives and show what we've done today. So we've introduced a few new trigonometric identities. We know how to solve difficult equations, simplify expressions, and prove identities. And next week we'd be looking at graphs, what the graphs look like of these, and various different things that you can expand on with this. Brilliant. Thank you so much. Bye bye.